architect at Tengen. So I help customers build and deploy apps on MongoDB. So I saw that there was sort of a funky title for the event. It was like the SQL you love or the SQL you know in MongoDB or something. And then the description was more about schema and how you really go about representing data that was in a relational database in MongoDB. So, which really comes down to schema design and how you design your documents in Mongo and what kind of performance you can get from doing each thing and how you can manage that. So, I want to keep this really interactive. Don't feel, if you have a question, don't feel like you need to wait to the end. Please interrupt me. Please ask me. I have some slides, so we'll talk about the slides, but really, we just talk Mongo too. So if you have general questions, please feel free to stop me and ask them.
Anybody got any questions right now? No?
I'm just going to heckler in the back. So, here's the agenda that I have laid out. We'll talk just real briefly about the MongoDB data model, parallels between Mongo and a relational database, as well as embedding versus linking documents, and when you might want to use either one of those, as well as kind of denormalization in general and what that means. And lastly, kind of managing arrays and schema decisions when sharding. So this is what I have as far as slides, but feel free to stop me and ask them. So everyone, it sounds like everyone had their hands in there, so everyone knows what we're looking at here, right? JSON document. So that's how we store data in MongoDB. Well, we actually do a binary serialization of JSON called vson, but for all intents and purposes, from a development perspective, you can think of it as persisting JSON documents in Mongo. So you load and query, your documents look like this. The nice thing too is that you can think of them as key value pairs, except the differentiator I would say is that every value doesn't have to be just a constant. It can be an array, it can be another document, it can be an array of sub-documents, etc. And because of MongoDB's indexing model, which we're not going to dig too deep into unless there's some questions about it, you can index values inside those embedded documents. So you don't only need to index, you don't only have the ability to index these top-level key values. You can index the name here, or you can index key relational here, things like that. Sorry, and I have to take a little while to switch slides. So as far as generally what it means to go from a relational data model to a document-oriented data model, it means that you need to denormalize your data a bit. And denormalize sounds like a bad word, but it's actually not a bad thing at all to denormalize your data. And a lot of your architecture things have been doing denormalization for a long time. It's just that relational databases typically represent things in a normalized form. And I know that most people in this room understand what normalized means, but just to sort of review for those who don't, normalized is the idea where you represent everything only once, and then you link out to other places where that data has the chance of being duplicated, and instead of duplicating that data, you have a single place where it's referenced. So an example would be if we had blog posts in a relational database. For the author value of that blog post, it might link out to an author's table, and then that table would have the author in it. And for any comments in the blog post, it would link out to the comments table, and there would be all these joins that would count. So it can be an elegant way to represent data, and in many cases, sometimes it can be the best way to represent data. But what we're coming with Mongo is certainly not the only way to represent data, and it makes sense to represent things as documents in many cases. So when we go to a denormalized data model, it means a couple things. It means that when you're querying, you no longer have to query and then join onto another table. So joins can be expensive because you're joining all these tables back and forth. And the one thing with joins too is that if you want to scale your architecture horizontally, especially in multiple data centers or in the cloud or something like that, and you happen to join on a value that's in another table that's in another data center, then you'll be subject to the latency of the internet. So it doesn't always scale. So by going with the denormalized data model, pretty much means that every time you retrieve a document in Mongo or in whatever database you're using, you're retrieving that entire document. So it's just a very simple key lookup, key lookup, key lookup. The differentiator that I would say one of the big differentiators though as far as Mongo not being like many of the key lookup stores is that you can have any number of secondary indexes. So you don't just have to query on a primary. You can be on any one of these, you can query any one of these fields that you have an index on and bring back the document. So as far as what denormalization means, it means that instead of having this represented as 6 or 7 different tables, It's all going to be represented as a single document. Questions so far?
Right, so
Yeah.
that's because disk space is cheap now, right?
Right. So the way Mongo is architected is that, yes, you might take up more space, but disk is cheap, especially Mongo is really architected to work on cheap local storage. You don't need to have an expensive shared disk. Every machine has its own cheap local disk. And so while you can see here that one of the things with denormalization is that you may end up duplicating more data.
Who cares?
Well, who cares?
There are several other arguments, right? This is not meant to be a data warehouse. If you're in a data warehouse, you're going to spread the data because you're not quite sure how you're going to join it, how you want to join it, what you're going to configure later. Here, this is meant to be an operational data store where you're going to have an application that's going to have a very intensive use of it, either for writes or reads, but you have some idea of how this is going to be used. And in that case, in the memory versus time compromise that you have to make, yes, disk is cheaper. And therefore, it's possible to optimize for time by changing the way you represent data to make sure the application has really the access it needs.
So real quick, parallels of when you're coming from a relational database to MongoDB, how do you kind of wrap your brain around it? I would like to say that at first it's this total mind shift where, especially someone who's been working with a relational database for some period of time, you have to adjust to a document-oriented database, and it's this new way of looking at things. And then when you kind of peel back the layers of the onion, a lot of the things are actually really similar. So a database stores records. Any database is going to store some number of records. In a relational database, that record is a row. In Mongo, that record is a document. You have a bunch of rows that have the same schema and represent similar data. Those rows are going to make up a table. In Mongo, if you have a bunch of documents that look the same, well, then those are going to represent a collection. So in a relational database, you have tables. In Mongo, you have collections, columns. So we have rows with a bunch of columns. That's all your values there. In Mongo, you have those key value pairs. And every key value pair is going to be like essentially a column. The main difference here is that because there is no schema object in Mongo, there's no enforcement that every document has to have the same columns. You can really mix it up. Obviously, you're going to want some type of similar structure because you want to be able to query and display that data. If every document in a collection has completely different data, then your application's not going to be able to make much use of it. Indexes are actually, though, they're pretty much the same. So especially in Mongo, the way indexes work, very similar to how relational database indexes work. We use B-tree indexes. It's pretty much the same. The joins is where there's a big difference as well. So it's pretty much a design decision in MongoDB that we're not going to do database level joins. The reason why is because you don't need them if you're embedding documents. And they don't scale with Mongo architecture because we want geographically distributed data centers in the cloud, cheap hardware, and if you're having to join across partitioned data at each time different data centers, then you're not going to get good performance. Joins only work well if they're either on the same machine or if they're on machines that are in the same data center hooked up over 10 gig or something like that. And the thing where there's really no parallel is the schema object. So in a relational database, you can look at a schema, you can see exactly what all the fields are going to have, and you can analyze the schema. And in Mongo, there's no such thing. In Mongo, it's really an implied schema based on similar document structure. So in every collection, you're going to have your documents that are going to be representing some type of similar kind of data, and then those documents are going to have similar structure, and you're going to have an implied schema on that.
So basically, fill in the box, you put down client code.
Sure.
Yeah.
I mean, you put whatever. I mean, it's not except the schema object is something you can look at. I mean, you can look at code, but it's not really like describing your data model necessarily. You can kind of figure it out. But yeah.
So I had a question about this row document thing, and my question is, to give an example, Commission Junction, advertisers have ads. Those are links. In some of our database tables, those are rows. So link A has this many impressions, clicks, and sales. Link B has this many impression, clicks, and sales. You could store that in Mongo as link A is one document, link B is one document for a given day. We do a lot of by day reporting. We could do by hour reporting. What I've kind of thought and played with recently was not doing that, not doing row mapping to row mapping, not treating Mongo as a database, row by row. Instead, in one document collect all the ads for that one day, or all the ads for that 1 hour, or whatever granularity you would want. And I've seen, I mean, just a rethinking of way for me, for a database guy, to rethink, why do I have to store a row here and a row here? Because you could have like 1 million rows or 1 million ads for one day. That's that would be 1 million documents in Mongo, which is really slow. Or I can make one document in Mongo for those 1 million ads, but then I have a later question, which is document size, optimal
Right.
documents.
And we'll get into documents. But yeah, so I mean, I think basically you hit on a big point. So if we were to just do this one-to-one mapping though, this is still sort of correct. That this is how, I mean, a table is like a collection of Mongo, a document is like a row. But you hit on a good point that doesn't necessarily mean that you just want to take your rows and dump them into Mongo's documents. There are many places where it's going to be there's a more intelligent way to represent data. One kind of story that I mentioned in the value book meeting yesterday, for those who were there, you'll hear a little repeat, but was working with a large educational online university. And what they had is they had this issue where in their relational database that they were storing, they had a list of classes, or a table of classes, and they had a table of students, and they had a table of professors, and they had a table of sections. They had everything so nicely laid out. You had all these tables. The problem was, we looked at their usage tables, and what was the most common query that was over 78% of the time? Well, it turned out the most common query that they had was for something that we called a schedule object, which was for a student. Give me that student's class, what time his class is, who his professor is, what room it's in, this and that. It turned out that was actually running over 100 joins every time just to get that data. So for just a student to go and say, what class am I in at 3 p.m. today, that took 2.5 seconds, which is actually pretty fast considering how to join these so many tables. So what we did though, is we didn't just take their table of professors, or table of this and represent them as rows in Mongo. What we did is then we said, okay, well if 78% of the time you're actually querying for this schedule object, what if we were to represent the data in Mongo as schedule objects? And then we could even still represent the tables of the professors and the tables of this and that. And we have a little bit of data duplication. So when you would do the updates and things like that, there were a couple more, you have to update them in a couple places. Now that being said, the updates were like 3% of the queries. And the retrievals of the schedule objects were 78%. So now instead of doing one query every 3 seconds, they can do thousands of queries per 1 second. So kind of getting the big win there. But I guess the key takeaway here is not necessarily that this is the be all and all of use cases, but that you're right in that you don't just want to take rows you have in a relational database and just throw them into documents if necessary.
Yeah.
Long-winded answer.
One advantage is that another way to answer that is that because the document structure is inherently very flexible, you can map the structures you use in your application much closer for persistence. Right? Instead of having to go from the way you conceive of data in your application and map this to the relational data model, and there is a bridge which is not always trivial now. You can usually map it from the way it's used in your application directly into the persistent store.
So I got a question about what you're talking about, where you map schedule as an object.
Yeah.
You're saying that one of the downside is sometimes when you want to make an update, you have to update it in different places because there's.
Right.
So in that case, because I played with Mongo a little bit and trying to figure this out, if an update goes wrong, let's say updates 2 out of 3 places, does that mean we just have to write the code to handle that failure and say roll back and try again?
So the short answer is yes.
Okay.
That's the short answer. The longer answer is, so every, basically, yeah, because that's one of the difference of Mongo versus a relational database, where you can commit 30 rows with a single transaction and roll them back. With Mongo, so let me just finish that. With Mongo, every individual document update or insert is going to be its own transaction, its own atomic update. But if you need to update 4 or 5, that is not going to be a database level single transaction. So what we typically recommend doing in that case is to, when you're writing the data, give it a transaction in the document. So it's an application level ID. And then know that if it wasn't written, to delete all of them. But it's at level code to manage that versus database level code. So it's just one of the trade-offs.
I was just going to ask maybe later on or now, have you ever seen the opposite, which is document explosion? Someone getting overly too complicated with how they create documents and like a, you know. I mean, how many collections can you have in a document? How many drills or how many, you know, subarrays?
You can nest down pretty much infinitely. I mean,
Right.
but you wouldn't want to necessarily. So I think, okay, to answer your question, I think that when we start to see this document explosion, that's really just more of a sign of bad schema design. And that's when you get on a whiteboard and talk about, really, let's get back to basics, because it doesn't need to be that complicated. It can be simple. You know, and so that's me. Animation. I forgot I had an animation. I feel silly having one. So in any case, so the question, okay, so we talked about this, and as far as how do you make the documents look, the basic question, and this kind of goes back to that example I had, was, well, what are you going to do with the data? How are you going to retrieve? Think of what the most common way you're going to retrieve it is, and try to represent the data that way. A simple use case is if you're using things like ORMs, like object relational mappers, to persist your data in a relational database. When you write that data, it could have some data on, you know, all these number of tables that it's doing joins, and like, as a developer, you might not even necessarily realize that it's doing that. Think of representing that data in Mongo just as your persistent. An object equals a document. And then so once you kind of realize what you're going to do with the data, then the big question is, in the case, okay, so the big question is then, well, there's certain times where it might make sense to join to another table, and in that case, does it make more sense to do an embedded document or to link out to another document? And to be clear, when I say link, I mean just basically having a reference of one embedding to another where they reference each other. That's not a database maintained link, so it's not exactly like a join, but you can make it work like an application level join where you'd be getting the ID, and then you'd be querying the next collection with that ID. Is that the fastest way to query data in MongoDB? No, absolutely not. The fastest way is to just query, retrieve document, query, retrieve document, query, retrieve document. But once again, going to what your app's doing, if that's just a small percentage, or even a decent percentage, but less than half of the use case, it might make more sense to link to that data instead. So I'm going to go through a few examples of embedding versus linking. And I don't actually need any example I'm going to be showing is necessarily like, for this example, the way that you should do it, but it will just kind of give some pros and cons of the different ones. And feel free to to interrupt me if something doesn't make sense. Okay, so we're going to be talking about blog posts now. That's kind of the motif for embedding versus linking and linking. So in this case, let's just say you're representing blog posts in MongoDB. Pretty good use case. A blog post can be thought of as a document. You can persist a document in Mongo. That's great. But how are you going to deal with comments? Do you want to embed the comments inside the blog post document? Or do you want to create a separate collection of comments and represent them there? So first, let's look at the fully embedded case. And what are the nice things about it? So here we've got this blog post, we've got the text, and the comments fully embedded. Well, one, you can query the comments or the blog, and you'll still get the document back. So if you want to put indexes on the comments, you can do that, and the query on the comments is still going to return the entire blog post. The other two is cleanly encapsulated. If you've got one collection of blog posts, you have all these documents. If there's 5,000 blog posts, you're going to have 5,000 documents. It's nice. It's pretty easy to manage. As far as the negatives of it, basically, MongoDB has a 16 megabyte document size limit. That document size limit, there's actually no technical reason that we have it. The reason we have it is because we feel that if your documents get larger than 16 megabytes, then we may have another schema design discussion. It's just kind of one of those things. But basically, if your document's getting so big, every time you're doing a lookup on this document, you're going to be retrieving this big document, and that's not that optimal. And what if you want to query for comments and not the blog post? You can still query for a set of comments, but you can't really query for individual comments.
You could index the comments though, right? You just have to pull the whole document.
Yeah, oh, absolutely. So that's what I'm saying here, basically the first pro there. You can index the comments and you can query, you're just going to get the whole document back, the blog post document back. Yeah. Okay, so the second option then is we're going to make this distinction. We're going to say, all right, we're going to make two collections. So I can say, I don't specify that here, but we'll have a collection of blog posts, we'll have a collection of comments, and we'll stick the blog posts in one collection and the comments in another. Okay, so what's the good and the bad here? So this is great. For every blog post, we're still going to have one document. For every comment, we're going to have one document. So let's think of what are our common use cases here. For retrieving the blog post, that's nice, because now we can just query the blog post, get it back, and it's a small document. It's never going to grow in size. That's also nice. Because the way MongoDB works, actually, just to kind of step back a little bit, is that when you insert a document, well, so MongoDB does in-place updates. And so when you update a document in MongoDB, it's going to go and it's going to update the value in place. If you're just incrementing one value, it's only going to increment that single value. So it's really efficient for updates. And then as you're inserting data, Mongo is going to allocate slightly more space than the document takes up. So if the document is 10K, we might allocate 11K. The nice thing is that if you push to some arrays, it can still grow within its space. But think about if we're pushing stuff here like on a bookshelf, and then if all of a sudden the document grows to it can no longer fit its section of the bookshelf, then we have no other option but to then reinsert a new document at the end of the shelf. It's not necessarily a bad thing. However, it does cause some database fragmentation. And at this current stage, MongoDB does not do online compaction. So it's not going to go in and reclean that space up. Still with MongoDB, with replication and things like that, there's still ways that you can take one machine down, compact it, bring it up, take another one down, compact it, and you won't have any downtime. But it's still that you don't really want to generally design your database so that you're constantly creating fragmentation. In future versions, MongoDB is going to have online compaction. But even once it has online compaction, you probably still want it to not have to compact it if you can avoid it. So that's kind of one of the things that's nice about documents that aren't infinitely growing in size. So in this case here, we will create a document for the comments, a document for the blog post. As comments come in, we're going to push to this array, and we're going to reference between the two. So as far as the, yeah.
But Mongo has a feature that says, give me back this field in that document. Does it actually, do you take the hit for reading the whole entire thing just to return that one field? Because you can set that flag.
So if you want to just bring back a single field in a document, there's a couple ways you can do it. So the first one is using a covered index. If you declare a covered index, like let's say you say, okay, I want to query on blog title and I want to return back blog text. You can put a compound index on blog title and blog text. So that basically think of the indexes as in Mongo is you can use the index to find the document and then you retrieve the document. With a covered index, you not only use the index to find the answer, but you also use the index to pull the answer back. So with a covered index, you can do it that way. If you're just specifying a projection on the way back, like don't return the entire document, then at the MongoDB level, at like the very low level, it is finding the right document, but it's not going to transmit that over the wire. So basically, the MongoDB overhead of finding the document is there, but there's no network overhead of transmitting the whole document.
So if I understand you, it's reading it into memory or however it does that, and then it takes the data you want and improves it to you. Is that right?
Are you talking about the covered indexes, or?
No, what you just described. If I'm digging into the document for one value, it's going to read the entire document into the Mongo memory.
Like if you had 15 megabytes of comments, but your initial blog metadata is only 2K. Does it read the 15 megabytes for all the blog posts, or would it only just read the 2K and then return back?
So you're saying if you have this document is 15 megabytes and you have 2K that you want to return back?
The blog title, the blog. If it was your first example.
Yeah.
One document.
So at the first example, then at the Mongo, like the low-level DB, it's going to find the document and grab the whole thing, and then it's going to transmit only
the 2K or whatever.
2K over the wire.
It'll read it off the disk, in other words.
Yeah. Okay.
Well, it'll read it where it can find it. MongoDB will try to keep as much of itself that it can in memory just by default. So if it's in memory, it'll read it from memory. If it's not in memory, it'll read it from disk. Okay. So as far as why this is good or why this is bad, so I have way too many animations. So the good part about this is we're talking about the idea of ever-increasing sizes of documents in Mongo and how that's just not the best way to represent data. So you avoid that with blog posts. And the blog post size is going to stay constant. And now you can still do what you did before. It's just two queries where you can search the comments and you can get back the blog post because you're going to get back the blog post comment ID, or the object ID, and then you do another lookup to get the blog post. So it's two queries. Is that bad? Is it good? Well, I don't know. Are your users querying a lot for comments? They're not querying for comments that often. Then if it's slightly more expensive than they got to look up, maybe it's not so bad. You could also think about possibly doing a little bit more data duplication where your comments are going to reduplicate some of the data in the blog post, like the title and things like that. That way you can bring back at least the title without having to do another lookup. And then when someone clicks the title, then you can go look at the blog post document. Just different ways of doing it. So the cons, so what happens if you have too many comments, if it gets slash dotted again, it goes over 16 megabytes, well then that's bad, so we have a 16 megabyte document. You don't want that. The other thing too is now you have to manage these documents. There's no database level management of these. It shouldn't be that hard to do in that you look at the document, you get an ID, you reference it to, they reference themselves, but just know that it's not the database doing it, it's you doing it.
Is there a case where the document ID could change, maybe not that the document ID changes, but the content of the document will become a different document and then that link is broken?
Okay, so if I've inserted a blog post and I have comments and they reference each other,
Yes.
but somehow we update this blog post and it's no longer that blog post.
Right.
But because we didn't update, it would still have the same object ID.
But,
Right, is that what you're asking?
Oh, no, I'm asking if I don't know in what situation this might happen.
Okay.
Could,
Right.
could the ID ever change?
Absolutely. Well, no, the ID is not going to change. So if you're doing the underscore ID, this I guess I didn't mention that every document that you insert in MongoDB is going to automatically get an underscore ID assigned to it. It's like our primary key. There's always an index on it. You don't need to use that to reference to each other, but I was just giving that as an example. So if you update that document, the underscore ID is never going to change. So if you have some broken app code that updates that document to a new blog post, but doesn't update, and it's, yeah, that would be bad.
So there is no integrity constraints imposed by Mongo, right?
Exactly. That's going to be at either the application level or, we have some mappers that work with MongoDB, and most of them are community built, but they all work a little bit differently. But each one of those, if you write to Mongo through these object mappers, then some of them have constraints there. Like I know I'm speaking to Java users, but I know that some of the Ruby mappers, I think like Mongoid or Mongo mapper, do almost like schema validation on insert. So what I would recommend doing is figure out what your code is that writes to the database, and once it's writing documents that you're happy with the consistency of them, don't mess with that code. That way you're not going to have documents that look different.
Okay, got a question about
Yeah.
the schema design. So I don't know if the hacker needs embedded where you can vote on comments and sort them by points. So how would that change the schema you talked about?
Good, that's a great question. Okay, so if we had the one before, it would be hard. If we had this right here, and you had to vote on comments, it would sort of be it was doable, but it's hard. It's hard logic to go and update individual comments because they're embedded inside of another document. So you have to grab this, and you have to step through these arrays and get the position of values in there, and then update those with the votes. That's basically what I'm saying. So like this is not a good way to represent that data, and I will example 3 would explain a better way to represent that stuff.
I looked at your slides before, that's why.
So that's a question on
Put over the softball, huh?
when you store a comment,
Yeah.
is it always, do you have to always be allocated a fixed length, you say it would be 11K, or depending on the length of the comment, it allocates something?
So what Mongo's gonna do, so let's forget comments for a second, let's just talk about the document in MongoDB.
Yeah.
When you put a document in MongoDB, that padding factor that it gives you is basically over time Mongo will watch and see if your documents are growing more or growing less. And if it senses that your documents are growing a lot, it will give you a little bit more padding. And if they're never growing, if you're adding updates, for example, it'll give you a padding factor of basically like 0. So it's not tunable right now at the database level. I'd like for it to be tunable, for me to say, give me 50% padding or 4% or whatever padding. It's not something that is tunable at this time. The only way to get yourself extra padding is that when you insert a document, you can insert a bunch of garbage.
Well, then the document follow will be based on its larger size.
Exactly.
So you kind of like have an expansion of the size of the document, depending on the
Absolutely.
Phoenix stuff.
Absolutely. Yes.
What if you had a date and you sharded off your the comment hour? You shard off your comment collection based off the hour. So in the first hour, your comments aren't going to grow.
Yeah.
So the second hour, it's not going to. I guess you would insert a new document for
So that's
different
probably not
hours.
the best strategy.
Yeah.
Actually, not to deflect your question, but in the very end, I have a slide about schema decisions when sharding. I know that sharding in MongoDB is kind of, I mean, we could spend an hour and a half just talking about MongoDB sharding. So let's kind of keep all the sharding discussions till the end, and we can kind of go into the architecture there. Sorry if that's.
Yeah, and I have one question about, like, look on that second the structure on the right there.
Yeah.
Say for whatever reason you needed to get all the unique authors, and that was a common thing you need to do. Would you just put an or could you put an index on author even though it's inside an array right there?
Yeah, you can. You can use the documentation step down for the index on comments dot author.
Okay.
Yeah. So let's look at the next example of how. So we talked about you can have them fully encapsulated, one blog post, all the comments, one document, or you can separate out the blog post and the comments. Comment 3 is what if you have the blog post still as its own document, and then every comment is its own separate document. So this is nice because there's a couple things that the properties that we avoid. We don't have the problem of infinitely growing arrays anymore. There is no such thing as growing documents. Every comment is a new document. We're happy. The other thing too is now we have access to individual comments. So it's very easy. This right, like I have not put IDs in here, but every comment has an ID. You can easily look up a comment based on that ID. When someone clicks to vote up that comment on Hacker News, you can then have a field in here that was votes, and then increment that down. So that's how you do that. So actually, and this is using the blog post and the comments. It's easy to help explain, but it's not necessarily the best. You know, maybe this is or isn't how you want to represent this specific data. But in general, how I like to represent data in Mongo is like this, where basically every action inserts a new document rather than giving you these arrays and things like that grow forever. So I think this is nice. As far as what are the pros and cons of this one? So now you can query individual documents, like you mentioned, where what are some of the votes up comments? What are some of the this or that? If somebody gets /doc, it's not a big deal. You just keep inserting new comments document. Never need to worry about document size. What's bad about it? Well, the common use case gets a little bit more complicated. You have a collection of comments, and these comments don't actually a collection of comments, and they were inserted in some order, and that doesn't necessarily represent which blog post they refer back to. So the common use case of like just give me the blog post and the 10 most recent comments is a little bit harder now, because now we're going to have to every comment is going to have like a blog post ID in it. We get the blog post, and then we're going to query the comments collection, and we'll return the comments with that blog post ID sorted by most recent or sorted by votes, which is something nice that we can do now with this data model. But there's more coding now just to do these standard use cases. Yeah.
You mentioned the indexes when you search it. Those are really going through my mind.
Okay.
So you query out, you get back data from them instead of getting already. I mean, this might not be a bad case for doing something, right? It's already indexed with the votes already, and you're not even hitting, it's not even pulling in from this necessary distinction. Depending on my camera. Is that kind of a good use case for them?
As in any search engine?
No. You're not. What do you call the indexes? The cover. The cover. Right.
Oh, a covered index. Okay.
Right.
Covered index. Okay. Is this a good use case for a covered index?
Yeah, I mean, so you kind of load all that stuff up into the index, and now you can pull it straight without having to.
Yeah, except the covered index is going to return a single value.
So it's only one type.
Yeah, it's a key. It's a query and a key return another.
So how many documents do you have in your collection?
There's no limit.
Oh, okay.
And
No, object ID, is that a date?
The object ID is default. I created in Mongo. It's like a hash, and I think date is somewhere in there.
There's a date in
So I
there.
think theoretically it is somewhat ascending. It doesn't look like a date, but it's an ascending key. But you can also specify your own object ID when you insert documents. So if you don't want that one, you can just specify your own.
But you could retrieve the date from that
From the ID.
From the ID.
Oh, absolutely. And there's always going to be an index on the underscore ID by default.
Some combination of the timestamp, the process ID, the ID of the machine.
So if I had to pick one of these three, I would pick this one. I like it the best. But like I said, keep in mind there's more code. You should just go and retrieve 10 comments. Yeah, I have great animations. So as far as basically just a little bit more about normalizing your data and what it means. So it's going to be faster. Just for everything we just talked about, the most joins you have is one. And those aren't even joins, they're application level joins. The reality is there's no joins, no database level joins. Which really lets you scale out horizontally rather than having to just buy a bigger box. It's also more object oriented. You write an object in your coding language, you persist it in Mongo. Write an object, you persist it, write it, persist it. You don't have to worry about that object actually being represented in 50 different tables. But there are application level implications, and the best one basically is Paul writes his blog post, and and one time he just tries to write his name Paul instead. So keep in mind from an application level that that's not so simple as changing one value in a relational database. It can still actually be quite fast in MongoDB, and you have an update command that will go through and update all the values that were named Paul and update them all to Paul or things like that, or anything that looks something like Paul you can update to it. But it's definitely more expensive than doing it in a relational database. So there's just implications. It's just a different way of representing it. So I think we've actually spoken a little bit about managing arrays through our database here, but that there's really like two things that are going to happen if you have arrays that are infinitely growing, and two things that are not great. And the first one is if the document hits the max document size of 16 megabytes, well then, I mean, once again, we should probably have a discussion about your schema. You don't want 16 megabyte documents constantly in an OLTP system just read really quickly. The other thing too is that if you keep having the document grow larger than its pre-allocated size. So one, this is annoying because one of the cool benefits of Mongo is that we're doing in-place updates, and that when you update the document, you update it in place. A lot of other, especially in the non-relational database space, a lot of the other products out there mean that every update is a new insert, or they just expire the old one and insert the new one. But if you're growing past your pre-allocated size, we're going to do it. We're going to have to insert a new document. You're going to cause fragmentation at your database layer. And that fragmentation, you have to do some compaction if you want that space back. Kind of a pain in the neck. The other thing too is the more that your documents grow, Mongo is going to realize, oh, this guy's documents keep growing, so when I insert documents, I should pre-allocate a bit more space. So even just the basic pre-allocate documents now are going to get larger. So something to manage. So basically, what's the hybrid of having arrays that are growing, but still not having each individual document? And actually, once again, caveat. The example I'm giving, I'm not saying is the best way to represent the example I'm showing, but it's just another way to do things. And so that's to limit your array length, where you can have a collection of comments, but each comment's document is actually a series of comments. And then you have some app level code so that when your comments hit 10 comments, then you'll push to, or 3 or 4 comments, you'll push to the next one. So your documents will actually be some set of some number of comments that kind of link to each other. The comments is maybe not the best example to show why this would be a good use case, but it could be. So maybe it's time series data, for example, where every one of these sets of documents is what has happened over the past minute on your website or something like that. That's actually our Mongo monitoring service. That's what it does. It collects minute level data and it goes. So it's just an example. Here in this case, you'll make sure that your arrays are going to grow, but they're never going to go past the pre-allocated, or past the document size limit, and they're never going to get too big. And it should just be kind of a fine way of representing things. Obviously, it's not a great way to represent comments necessarily, depending on your use case, but it's just another example.
So I have a question about the monitoring.
Sure.
So wouldn't that be a good case to have each contrary than to one document.
Yes.
So you're saying that you can have a document that contains 10 things in an array and then link to the next and then link to the next.
Well, in our Mongo monitors, we don't represent it as things that link, infinitely to each other, but we represent when we take a statistic, it's a minute of data.
So each document represents 1 minute.
With a timestamp on it and all that, but they don't actually link to each other.
Right.
Yeah.
Okay, so couldn't you still, so I guess my question is, would that still be better represented as individual, just a whole bunch of individual events, individual documents? What is a big advantage with a minute worth of events?
So depending on how you're using your data, it could be better to store things differently. For us, this is a monitoring service, and we're showing people time series of data over time. So it makes a lot of sense for us to show, at the minute level. Or we can get rid of the old stuff, and then we're just playing a graph. But if you're not having monitoring, maybe you're having something, it's very, the schema design is very application specific.
I see. So
But on this application, what's the value of Mongo, we're talking about schema-less design here, the value of Mongo is the flexibility while you're writing the app. It's agile development. That is the real value that you're getting, which is implicit from this. So the guy who wrote the MMS, the monitoring service, wrote it, first of all, in 3 months. It was deployed in 3 months. But he changed the schema with experience from the beta test 5 or 6 times. And was able to do that while changing his development and really sort of accelerating through the changes, like, this is actually not going to work, this is not going to work, this is going to be this problem. And he was able to change his schema and modify the app very quickly to be able to get this to happen.
Yes.
Overhead is the one to add to the system.
Okay, so we're talking about, we're talking about schema anymore, we're talking about the Mongo monitoring service in general. Is that what you're asking? Yeah, okay, so just to back up. So one thing that Tangent company offers, we have something called the Mongo monitoring service. And what that does, there's so many different ways to monitor your system. Some people like Cacti, Nagios. We have a software as a service where you can log in, and there's a Python agent that you'll install in your system, and it will transmit performance statistics to us every minute or so. So it's actually very, very low overhead. All it does is once a minute, it does a query on the MongoStat, on the collection where MongoStat's getting the data, and just sends the performance stats to Mongo. And then the nice thing is then you can log in and you can see other stats.
Alright, so it's using MongoStat.
Using MongoStat, so yeah, the stuff that you see in MongoStat, MongoStat is, you can look and see where the page faults are and things like that. It's a Mongo monitoring tool. It uses MongoStat, but it also, there's a plugin that will also transmit hardware statistics. So you can see is your CPU pin, et cetera, et cetera, et cetera. So that's cool. And the other thing that it does is MongoStat tells you what's happening right now. This holds data for 24 hours, actually for longer, but you can visualize it on the website for 24 hours. You can see what happened last night, or something like that. Yeah.
It also drives targeted advertising, like for RAM prices,
What's
No, I'm just kidding. You can see the stats. These machines are all out of memory.
Really good idea.
Just throw some ads for RAM.
You should click this one.
Well, can you give them some specs too about MMS and how many metrics we're tracking a day and
Yeah, so
how efficient Mongo is?
We have this monitoring service, basically, so just kind of another performance stat for Mongo. We have this Mongo monitoring service, and a lot of Mongo users are using it because it's totally free. They just wire up, they click it, and they can see their statistics. So on 9 servers, we're actually taking 3 billion writes a day. So I'm just kind of giving an example of the scalability. Unfortunately, I just put up this big architecture diagram, and it's like we can talk about this for an hour itself, but we don't have time to do that. But who knows how MongoDB sharding works? Okay, so less hands with that. So I'll just give a brief 2-second overview, which will not be enough, but if you have more questions about it, feel free to email me, kevin@tangent.com, and we can talk MongoDB sharding. But essentially, we recommend that the basic unit of deployment MongoDB is a replicate set. We have some replication, there's a single primary where writes go in, some number of secondaries where there's an asynchronous replication. If you get to the point though where your write scalability or your write throughput is overwhelming a single machine, or your data set is so large where the indexes can no longer fit in memory, then it makes sense to spread that out across multiple replica sets, which are shards. And the way that it works in Mongo is not like a MySQL manually sharding. What happens is that when you decide to shard, Mongo, you're going to pick a shard key. So this is what we talked about before. You had asked a question, right? You're going to pick a key, and Mongo's going to partition your data based on that key. So let's give an example of date. So let's just say you were to shard on date, and every block was had date. Let's say you started out with only one shard here. You didn't have these four, you just had one. So when you tell Mongo enable sharding on this replica set, what it's going to do is it's going to look at all your data in that collection, and it's going to basically scan it based on its date. And it's going to then group it into small buckets or ranges that we call chunks. And each chunk is going to have some range of dates. So if you have data from 1700 to 2000, then based on the number of documents, it's going to keep every chunk the same. So if 1700 to 1705, that would be 20 documents. Well, it's actually based on file size, but you imagine some set of ranges here. 1705 to 1718, 1719 to 1740, 1740 to 1750, so you have these chunks. Okay? And then when you add another shard, it will then migrate some chunks over to this, well, it'll migrate half the chunks over here. If you add a third shard, it'll then migrate chunks from shard 1 and 2 to shard 3. So basically, it has these mini buckets of ranges called chunks that it migrates to keep the shards even. Your application never needs to know that you're in a sharded configuration. We have this process here called MongoS, which typically has a tight coupling with your application server. So it's on the same machine typically, your app server, and is it on the same machine as MongoS? Instead of your app server talking to the database, it talks to MongoS on localhost, and then MongoS talks to all the shards. So MongoS is a stateless process. You can scale it out if you scale your app server. You could have 1 if you don't have a lot of load, and you could have 12 if you have a lot of load. But
And then you can go back to 1.
right. You can do whatever you want. So it's totally elastic in that sense. But the way it works here is that when you're querying or when you're loading data, based on the key that you've decided to shard on, is where MongoS is going to send the data. So let's give that example of date, for example. Let's just say that you are sharding your data on date. Okay, well, so we have some examples here of good keys, etc. So when you're sharding your data, think about all these shards partitioning your data. Realize that your application isn't going to notice the difference. To your app, it looks like you're just querying Mongo. It doesn't know that it's partitioned out across all these things here. But can you intelligently partition the data, first of all? And what I mean by that is, can you think of a way that basically apps patterns can optimize hits to different shards? Basically, when you're doing a lot of writes, can you make it so that you're evenly writing across all the shards? And then when you're doing the reads, you optimize those as well. So first thing is, will this partitioning create hotspots? So in the case of sharding by date, let's just say you were in an archiving site and people were primarily reading you for newspapers. And you had the 1800s to the 1900s, all the newspapers. Well, and a lot of the queries were based on the date. So that's nice. You're sharding on date because then you can route the queries to the exact shard. Because MongoS, that process I mentioned on the top, knows that shard key. So if you're querying on the key that you're sharding on, MongoS can route that query directly to the shard where the data lives. If you're querying on anything else, MongoS has to ask all the shards for the data, and then if none of them have the data except for one, then you'll have the data returned. So it's not necessarily expensive, but it's more expensive than having to talk to one. As far as hotspots as well, so let's just say we're sharding on date again, but we're doing a logging application where we're always writing newest data. Because it's a logging application that we're writing what's happening right now. We remember how Mongo has these partitions of ranges called chunks. If you're always writing to the same range where that data goes, then Mongo is going to be constantly splitting that chunk and then migrating these chunks to other shards. So you can add as many shards as you want. You're not gaining write scalability because you're going to write to the same place. Does that make sense? Okay. So then the last thing is, partitioning actually improve our performance. So a good example here is, well, actually let's see what examples I have on this line here. There we go. Okay. Okay. That's our key table. Constantly sharding on the date field or sharding on the date field and constantly inserting the most recent data, so logging. maybe a good example, and I put an asterisk there, but let's just say you had, let's go back to blog posts. Let's just say you had thousands and thousands of authors. So you had a high number of cardinality on your author because you have so many of them. Well, that could be a good shard key example. So if we have these range of author names that are alphabetical, and theoretically, as blog posts come in, they're coming in, with, let's just say, even distribution in the alphabet, then it will have a pretty much random distribution for rights. So as you add more shards, you gain more right scalability. When it comes to reads, if people are querying on the author field a lot, even all blog posts by John, then that MongoS process can route the query directly to the right shard where John's articles are, rather than having to ask all the shards. So that's why I put a star here, because if you're not querying on John a lot, or on the author a lot, then maybe that's not a good shard. But the idea is, can we somehow do a combination of optimizing our rights to not talk to every shard, as well as giving distributed rights? Yeah.
Off the top of your head, what is actually a good shard key for logging data?
There could be a bunch of them. One of them that was, so it depends if you're logging a single system, or a lot of people are using it to aggregate all the logs, but one that's good is often error message. So if you have a large variety of error messages, then that's good, because it's going to be kind of a random distribution, and people are often querying on the error message, like, I have this error, please give me all values back that are this error.
Or the timestamp.
Nice.
Or the timestamp.
So timestamp is probably not a good one for log, because we have these ranges, and it's always going to be writing to the same range, which is of newest data. And so you get no write scalability as you add shards, and the rebalancer is going to constantly be moving chunks to other shards.
Your error handler might have the same problem too if you have the same error code every time.
Exactly. So if you have the same error, you're going to have the same thing. So
hashes?
Yes. So you can right now you can hash at the app level. So you have to come up with your own hash. The question was, can you use a hash code or a hash value for sharding? At the app level, you have to create your own hash. But in the next version of Mongo, which will be out in hopefully a month or 6 weeks or so, that'll have MD5 hashing based in there. So that will give you a pure random distribution of rights. But the thing also with your logging app is, are you querying a lot? Right. Or no? If you're not reading a lot, then a hash is probably perfect. Who cares? You just want to make sure that you can handle all the logs.
Can you change the sharding too?
No, not really. So if you can imagine, you have all these. That's why we always recommend start with the replica set, learn your app's performance characteristics. Honestly, the easiest way to change your shard key is to bring up a separate instance of Mongo next to it and redump in all the data. Because you've got all these ranges, and these ranges aren't, if you're going to change the key, these ranges are no longer relevant. So it's like this crazy process.
So do you specify the ranges for the shard key at the time in the config servers, or?
No, you don't specify the ranges. Mongo will automatically chunk the ranges for you. If you want, you can turn off the rebalancer and you can do all that stuff yourself, but it's typically not really recommended.
Is there a limit for the rebalancing? It's possible to do that. It's possible to manually set the ranges. If you know your data set for some reason you know that this is a good way to do it. Right? And then it won't be dynamic again. Is there, what kind of penalty is there for the automatic rebalancing?
So the penalty is really your disk. And that, so think about automatic rebalancing. First of all, if you have an even distribution of shards, there might not be that much rebalancing that's happening. So the two places where you can have the most, so I would say in that case, the penalty is very minimal, because these chunks are only about 32 megabytes in size. So moving 32 megabytes from here to there is not a big deal. But there is a larger penalty when you add a new shard, for example. Because then if you have 3 shards and you add a 4th, it's going to migrate chunks from all 3 to the 4th. So that's heavy on the disk. So if you think sharding is a good idea, great. Just make sure that you don't have a sharding configuration at 90% load, and then add a full shard.
It's going to migrate to the next block of sharding.
So
parts of it are going to be there, or are each of them going to have distinct blocks of information?
So in this case right here, if you had 4 shards, every shard in here is going to have some number of little mini ranges of chunks. And if you add a 5th, chunks from all 4 are going to migrate over to keep them in balance.
So, question though. So, let's say that you're doing, the like this a random hash key value you're inserting.
and all 4 of them are empty to begin with. Is it going to start off by building up one shard and then starting to split from there, or is it going to distribute that across the 4 to begin with?
It's just, you have nothing.